All right, so second section we're going to look at this week is 3.4, and it's on synthetic division, which your book calls Horner's algorithm. So if you see that in the book, just know that that means synthetic division, and rational zeros. So first question, what does rational mean again? We talked about that early on. But if a number is rational, Matt?
It's real.
True. If a number is rational, it is automatically real. But what makes a number rational? Because I can think of numbers that are real that aren't rational, so we gotta just make sure we narrow it down a little.
Like it's a number that like you can see like the end of, or like that you can like. Do you know what I mean? Like because you can't like see infinity and you can't like see the square root of 2. Did you know what I mean?
Well, this is a number that you don't, there's no end to it. It just keeps repeating. But that is rational. That is a rational number. Yeah?
Does it have no end?
No, rational numbers can end. This particular rational number repeats forever without ending. But rational numbers can end. Yeah?
I was going to say, irrational is like a never-ending number without any patterns, but I don't know about rational. Like,
there's a certain way you can write a rational number. Yeah?
You put like the dash over the top of a rational number where you can't put like the little dash on top of a non-rational number.
Like the repeating symbol?
Yeah, like the repeating symbol.
So there are rational numbers that don't need this dash. This is a rational number. 0.25. Yeah?
So rational would be where either it doesn't repeat or if it does have a predictable pattern.
Yes, and you, because what you just said, you can write your number as a fraction. So the key with rational numbers is they can be written as fractions. And if you're wondering, that's 1/9. 0.1 repeat. So I'm gonna show you a technique that will help you to find rational zeros, not irrational. Irrational is a little harder. You need quadratic formula or your graph, but we can find rational using a little system by hand. So some functions have a combination of both, rational and irrational. If you were to graph this, and I said to you, where does it cross the x-axis? It would cross the x-axis at the square root of 3 and the negative square root of 3. So the two answers to this problem would be irrational. Versus if I change that -3 to a -4, then the two answers would be rational, 2 and -2. So the theorem that allows us to find rational roots is called the rational root theorem, which if you see me write RRT, rational root theorem. All right, first of all, you've got a polynomial. It doesn't really matter how long it is or how many terms are in it. All that matters is you write it in descending order. Highest exponent first, all the way down to the lowest exponent or constant. And for the rational root theorem to work, I have to have a constant in the problem. All right, so what that says, to make sure we remember, this symbol right here means for all. Why is it an upside down A? I don't know. But it basically says for all values of n, the number in front is an element of the rational numbers, okay? Which means the coefficients have to be fractions at worst. I can't give you a problem like this. The coefficient of the x cubed term is the square root of 3. It's a polynomial, but you can't use the rational root theorem on it because of this. Okay, so the numbers for all coefficients, they have to be rational numbers. That's what this says in fancy math writing. The other thing it says, the last part, this is a little easier, is it says that the first term and the last term cannot be a 0. Okay, the first term and the last term can't be 0. It's not if you had a 0 that they wouldn't have roots. It's that if you had a 0, the rational root theorem doesn't work. So you'd have to use something else. Okay. So, I'm going to show you how you figure out the rational zeros. Let's suppose that this is a rational 0. Alright, so if you have a rational root, okay, it can be written as a fraction. Everyone agrees that's what rational means now? Okay. P over Q. The question is, where would the P and the Q come from? Okay, they're hidden in that right there. Okay, in this somewhere. So where are they hidden? P could represent all the factors of the constant. Okay? The constant is what's at the end, a sub 0. So P is the numbers that are the factors of the constant, and Q are the factors of the leading coefficient. So what we have to do is make a list of factors here. So remember, a factor is just a number that goes evenly into something. Like the factors of 12, 1, 2, 3, 4, 6, and 12. Okay, so if your problem is going to have a rational root, that means it's going to be a fraction. And in your fraction, I guarantee you the number in the top is going to have to be a factor of the constant. The number in the bottom of your fraction has to be a factor of the leading coefficient. Always. That's how this theorem works. Now, what we're going to be doing here is basically generating a list of possibilities. Unfortunately, this theorem doesn't really narrow down which ones are correct. This theorem gives you a list of options. That's all that this theorem does. It's up to you now to look at that list of options and say, okay, I've got all these options. Here's the one that's actually correct. Or, after doing all that work, you know what? None of these are correct. And what that would mean is you have a problem without any rational zeros. Okay? So keep in mind, rational root theorem just gives you a list of stuff, and you have to look at that list and narrow it down. So let's try an example. I want to list all possible rational zeros for this polynomial. Okay, so we got 10x to the 5th minus 3x squared plus x minus 6. First thing we have to do is write down P and Q. So I said P can be any number that is a factor of the what?
Of the constant.
The constant. What is the constant here? 6. So P could be, you got a few different options. What are your factors of 6? That's half of them.
And then the negative.
The negatives. Yep. So you have 8 options for your numerator. Okay. So the numerator in your rational root has 8 different options. Plus or minus 1, 2, 3, 6. Now Q has to be a factor of what?
The leading coefficient.
Leading coefficient. So these are the numbers that would be in the denominator of our fraction. What are your factors of 10? Yep. So plus or minus 1,
Plus or minus 2,
2.
plus or minus 5, plus or minus 7.
Okay. So we've written down all the possible numerators we could have and all the possible denominators. So if this problem has a rational root, it has to look something like this. One of these numbers over one of these numbers. It has to be. There's no other fractions that this could ever have for where it would cross the x-axis. So now we have to make a list of all of them. And it seems like it could be a lot, and it is kind of a lot, but we'll do it very systematically. Yep.
So we can't have like decimals like 2.4 times, 2.5 times 4, which is equal to 10 as well.
You might end up with some decimals.
Okay.
Rational doesn't mean that it's an integer. Like, we're going to end up with 3/5 as one of our choices. And that's 0.6.
Alright.
So you will end up with some decimals. We don't change it to decimal. We'll just leave it. All right. So what we're going to do is write down possible rational roots. Again, possible. So we're going to write down every p divided by every q. Right? I'm going to start with 1. I could have 1 over 1. I could have 1 over 2. I could have 1 over 5. And I could have 1 over 10. That's every single possible rational root with 1 as the numerator. Those are all of them. Again, I don't know if any of those are even correct. But if there is one that has a 1 in the denominator, it is one of those 8. Right, now we'll go with 2. What would be my first possible rational root starting with 2? 2 over 1. And then the next one? Yeah, it would be 2 over 2, but we already have that one. So we don't have to write that one again. What would be the next one? 2/5, positive or negative. And what would be the last one? 2/10, which is 1/5. I already have that one. All right? So that's it for that. How about the first rational root starting with 3? With the numerator. So 3 over 1. What else? 3 over 2. We don't have that one. 3 over 5. We don't have that one. And 3 over 10. We don't have that one. And now with 6. Okay, what are your options there? 6 over 1, so 6. 6 over 2 is 3, we have that. 6 over 5, we don't have. And the last one? 6/10, which is 3/5. So, if this graph crosses the x-axis at a rational number, it has to be one of these. It cannot cross the x-axis anywhere else that's a fraction. It will be, that's not in that list. It has to be in that list if it crosses where you can write it as a fraction. Maybe it crosses where you can't write it as a fraction, and none of these are even right. Okay? But what we do now is we graph it on the calculator, and we look at it, and we say, okay, do any of these numbers even look remotely right? And then if they do, we'll check it out and see. But any questions on making this list? All right. So now, what I want to do is graph this, show that it only crosses the x-axis one time, and I want to show that where it crosses has to be irrational. Okay? So let's start by using our graphing calculator and see what happens. All right, so we've got 10x to the 5th minus 3x squared plus x minus 6. And I'll do zoom 6 just to reset this. Zoom 6. Okay, so we can see that it definitely crosses the x-axis one time. Now, I'm going to try to make that a little bigger. And when we look at that graph, it might be helpful to have it on the same page as these numbers. Let's this in right here. Let's look through our list of rational numbers and see if that looks close to any of them. What does that look like it crosses pretty close to? 1. Does it look like it crosses close to -1? No. So I'm going to cross out and try to do it in a different color. You don't have to cross these out in your notes because then you won't be able to read it, but I'm just narrowing my list down. Does it look anywhere close to positive or negative 0.5? Not really. So that's not an option. Positive or negative a fifth, that's 0.2. No. A tenth? No, not even close. Positive or negative 2? No. 2/5 is 0.4. No. 3? No. 1.5? Not really. 3/5? 0.6? Not really. 3/10? No, doesn't look close to that one. Plus or minus 6? No way. Now, 6/5, that's 1 1/5, 1.2. You could argue that maybe if you zoom in here more, 1.2, maybe it could be close to. That's the closest one we've had. It's definitely not negative 1.2. But I would say if where it crosses is close to any of these numbers, it's either going to be the +1 or the +6/5. Okay? Let's calculate the 0 and see which one it is, if any of them. Okay, so let's pick a point to the left. Let's go to the right and do a guess. We got 0.95. So 0.9505. Is that number either one of the options that we left? No. So this was a list of what kind of roots? Rational. What does that mean about this number?
Irrational.
It has to be irrational. Yep. So I'll show you how we would write the answer. So using the calculator, the graph has a root at 0.95. Since 0.95 is not in the list of rational options or possibilities, it must be irrational. Because the only way it could have been rational is it would have had to be one of the numbers in that list. It would have had to be, and it's not. So using the calculator, the graph has a root at 0.95. Since 0.95 is not in the list of rational possibilities, it must be irrational. Now, so it seems like it was a waste of time to write out all those rational roots because none of them even worked. Okay, that happens sometimes. We're going to do one where it does work, okay, eventually. Okay, so any questions on that one? Yeah.
So all this really helped us do is prove that the 0 is irrational?
Yeah.
Okay.
Yeah. It's nice when one of these numbers is actually where it does cross the axis. Then it's like you felt like you did something because it helped you to find it.
Yep.
But in this case, none of those numbers really helped us to do anything other than answer or prove this question. That's all they helped us to do. All right, so I think we're going to we're gonna find more rational zeros later. Okay, so we'll do another one of those, but we're gonna combine that with doing synthetic division. So synthetic division is a quick way to divide if you are dividing by something that's x minus a number. That's it. If you're dividing by x squared or x cubed or something more complicated, you got to go back to long division. But if you're dividing by something simple, like x minus 4, x minus 10, x plus 7, you got to be careful when it's plus, but we talked about that yesterday. You can use synthetic division. So I'm going to give you You know what? I think I'm just going to give you all the steps today first, and then we'll do a problem. So the first step is to write down the number after the minus sign. Okay, C. So like if I was dividing something by x minus 8, I would put an 8, positive 8, on the outside. Okay, so we make a little bracket, positive 8 on the outside, and then on the inside is the coefficients of your numerator. Okay, so just the numbers in front. So when you do synthetic division, you're not writing any letters the whole time, just numbers. Just like yesterday, if you are missing any powers, you have to fill in zeros for those powers. All right. Step 2. Okay, I'm just going to go through the steps. We'll explain them more when we do a problem. You're going to bring down your first coefficient. So you're basically just going to copy it down. Step 3. You're going to multiply the divisor, that's the number on the outside. That's what you would have right here. You're going to multiply that by the number you just brought down. You're going to multiply those two things together. The number on the outside and the number you just brought down, and you're going to put the answer in the second column. Okay, after you do that, you're going to have two numbers in a column to add up. You're going to add them up. And you basically repeat this until you're done. Okay. You'll know you're done because in the synthetic division, you're all the way as far to the right as you can go with your columns. There's no more columns. And then once you do that, with synthetic division, you're going to have a row of numbers at the bottom. We just have to interpret what that row of numbers means. Well, that row of numbers is basically coefficients. That's what they are. And the last number in that row is automatically a remainder. Right, so I'm going to bring this back up, and if I could have done 2 pages at the same time, I would have had this on the left and the problem on the right. But for some reason, the premium version of this expired. You can ask the other class, we talk about this frequently. And I can't show you 2 pages at the same time anymore. So I can only show you this, and then we'll come back to it. Hopefully I'll get that feature back again sometime. All right. So before I go to the next problem, I want to ask you something you're going to need to know to do it. So if I said to you, 2 is a root, what else does that mean? It's a 0, yeah. So it means 2 is a 0. It means 2 is an x-intercept. But it means something else. Yeah?
Is it that x minus 2 is a factor?
X minus 2 is a factor. Now, how would you prove that something is a factor of something else? What do you have to do? Divide it, okay? And then hope that what happens? The remainder is 0. Okay? So, to prove that this is a factor, all you'd have to do is divide it and hope you get a remainder of 0. And then, if you do get a remainder of 0, you have just proved that this is a factor, which also proves 2 is a root, because these are the same statement. Right? That's what you kind of have to think about in this problem. So it says here, show that 3/2 is a root. So that's the first step. Show that 3/2 is a root. And then we're going to be able to factor this cubic polynomial. So, to show 3/2 is a root, what else does that mean? If 3/2 is a root, yeah?
X minus 3/2 is a factor.
Right, so what I'm really going to do is show x minus 3/2 is a factor. That's what I'm going to show. And if I can show x minus 3/2 is a factor, then that will show what they really want. The 3/2 is a root. How am I going to show x minus 3/2 is a factor? What do I have to do? Yeah.
Divide the equation by x minus 3/2 and
Yeah.
the remainder is 0.
I'm going to do the division and get a remainder of 0. Now, I don't need to use long division because it's of the form x minus a number. So I can use synthetic division to do this out. So what number would you put on the outside? Put your 3/2 here. And now write the coefficients of your polynomial. 2, -5, 1, 3. And then put a line just like that. Leave a little bit of space because you're going to have to write numbers in right below. Okay. Step, I forget what step I called it, but you want to bring down the first term. Okay. So step 2, bring down the first coefficient. So I have a 2. What's the next step? To multiply the number on the outside by the number you just brought down. What's 3/2 times 2? 3. And you put the answer in the second column. So let's go back to the directions. Write the result in the second column. And now add the number we just wrote and my second coefficient. What's -5 plus 3? -2. And now do it again. And stop when you get to the last one. What's 3/2 times -2? -3. 1 plus -3? -2. So we get the same one again. And -2 times 3/2. What is it? -3. And what's 3 plus -3? 0. Now, go back here. The last row contains the coefficients of the quotient, and this is the key. The last number is the remainder. So, what did I just get for a remainder? 0. So I just proved that x minus 3/2 is a factor. Okay? This is your remainder. This is your constant. This is your x term. This is your x squared term. The next one would be your x cubed term. X to the 4th going up. So, we know that 2x cubed minus 5x squared plus x minus 3 plus x plus 3 equals, well, it factors into x minus 3/2. That's one of the factors. And now, think about the other factor. If I said to you 12 equals 3, that's a factor, and there's another factor that goes here. How do you figure out the factor that goes here? Divide. And this is the quotient. Well, we already have the quotient, right? The quotient is 2x squared minus 2x minus 2. That's the quotient. That's the quotient when you divide what we just did. So that's how you would factor this cubic. And the part that's handy about that is, if I asked you where this graph crosses the x-axis, you know that it crosses at 1.5. And this you could solve using the quadratic formula, because you took your problem that originally had a cubic and you factored it down, so now it's a quadratic. Okay? But you had to know this. And they gave you that in this problem. So, any questions on how we did the synthetic division? It always takes up the same amount of space. Once you set up the first row, you really just need about 3 rows. 1, 2, 3. It never goes more space than 3 rows. Every row. Yep.
So we don't need to keep on going after that? We just have to...
No, that's it.
That's
Yeah.
it.
So we did the first part. We showed that this was a root by showing this was a factor. And then the last part they said was to factor this. Factor just means write it as something times something.
Okay.
And I've done that.
Alright.
If you wanted to FOIL all this out, you should get that back. If you FOILed it out.
Okay, yeah.
That's it.
So you're not supposed to factor out the quadratic.
No, they didn't say to do that. I mean, sometimes if I have a nice quadratic, like if I had something like this, I may quickly write like x plus 2, x minus 2, if I quickly see how it would factor. But I'm not sure if that would factor nicely, and they really didn't say to do that. Kind of like if you had the number 24, and you factored it as 12 times 2. Well, you said factor it, and that's factoring technically. Could I break 12 down more? Sure. I could do like 3 times 4. And then I could break 4 down into 2 times 2. So usually you don't have to break it down that much. Okay, so let's just practice another synthetic division to find the remainder when we divide this by x plus 3. Now, technically, we're not supposed to divide by x plus something. It's only supposed to be x minus. So, can we rewrite this?
Yeah.
So it's x minus something, and whatever's in that box goes right here. -3. Yep. Any question why I'm using -3 in the synthetic division? Okay. What's going to be my numbers that I put here for my coefficients?
3, 7, 1.
3, 7, 0.
Oh, 0.
Yeah.
Oh, yeah, 0, 1.
So 3, 7, 0 for the x squared, 1, -11. And now I'm just going to go through this one at kind of a normal speed and show you how much faster it can be than long division. Okay, this would take a while with long division. Okay, but if I was going through it, I would say, all right, bring down the 3, multiply, -9, add, -2, multiply, 6, add, 6, multiply, -18, add, -17, oh boy, big arithmetic. -17 times -3 is what, 51? 51?
51.
And 51 minus 11 is 40. Double check me because I did it kind of fast and I was talking as I did it. But that's the whole division problem, done. A lot faster than long division. So the pattern is bring down, multiply, add. Okay? Multiply, add. Multiply, add. Multiply, add. You keep going. So what's the remainder here?
40.
Yep. Which means that x plus 3 is not a factor. So SD stands for synthetic division. I should have said that. SD is synthetic division. RRT is rational root theorem. And if you see GC, graphing calculator. Any questions on that one? All right. Let's show that 3 is not a 0. There's a couple ways I can do that. What's one way I can prove that 3 is not a root to that equation? Yeah?
Plug it in for x.
Yeah, I can use what I did yesterday, which is the remainder theorem. If you plug in the number for x, if you call this f of x, then f of 3 will give you the remainder. And if something is not a 0, you're just hoping for a remainder that's not 0. Now, I'll do it that way, but what's the other way I could do it? How we just did it. To show that 3 is not a 0, show that this is not a factor. Well, to show that x minus 3 is not a factor, just use synthetic division and see what you get. Okay? Again, I guess we could do it both ways because it doesn't take that long. But this is, let's see, 3 cubed. All right, what is 3 cubed? 27 times 2? 54. 3 squared is 9 times 5. Minus 6, minus 3. I mean, I can tell it's definitely not coming out to 0. 54 plus 45. 99. 99 minus 6. 93 minus 3. 90. So we got a remainder of 90, which proves that that's not a root. Now, with synthetic division, probably could do it just as fast. So let's put 3, and then 2, 5, negative 2, negative 3. 2, 5, negative 2, negative 3. I hope we get the same thing. If we don't, then I did something wrong. All right, bring down the 2. 3 times 2 is 6. 5 and 6 is 11. 3 times 11? 33 minus 2? 31. Seems good. 31 times 3 is 93. 93 minus 3. There you go.
So that's probably quicker though.
That one might be a little quicker, yeah. So either way, you get a remainder of 90, which proves it's not a root. Okay, so the strategies that we use when we have to find rational zeros is make a list of possibilities using the rational root theorem. Okay, now we're going to put everything together. Use your graphing calculator to narrow this list down, and then use synthetic division to prove that it actually is a root. Using the calculator, we can't just use the calculator to prove it's a root. Okay? We've got to use the synthetic division.
To have it come out to 0.
Yep, and you've got to hope that you get a remainder of 0. Okay. So they want us to find all rational zeros. So let's start with a list of options. What are your possibilities for P here?
0. Wait. 0.
Plus or minus 1 and 2. Those are your factors of the constant.
Oh.
What are your factors of the leading coefficient? And? Negative 1. So there's not a lot of options here. This is not going to be like the first problem. What are all the different possible rational roots? Plus or minus 1 over 1, which is just 1, and then plus or minus 2 over 1. So if this graph crosses the x-axis at a nice number, it's either plus or minus 1 or plus or minus 2. Now we're going to graph it, and we're going to zoom in on those spots. Okay? So the possibilities tells us where we need to look. We don't need to be looking at like 106, just between negative 2 and 2. So we got x cubed minus 3x minus 2. Graph. To me, it looks like 2 is a root. Right? And I actually think negative 1 is, what do we say about that when it comes up and touches it and bounces away? What do we remember what we call that? A double root, meaning this root occurs twice. Like if you factored it, it'd be like x plus 1, x plus 1. So my guess really quick when we find all the rational roots is it's going to factor as x plus 1, x plus 1, x minus 2. Okay? Just by looking at the graph.
Alright, let's put money on it.
So let's put money on it. I'm pretty sure I'm right. So let me fix my graph.
You're getting your money back.
Yeah, I know.
Alright, well, I'm back at the problem, but I need that to go away.
You're gonna have to give me
Okay. Hold. I'm just trying to get my cursor back where it was. Okay, now it's back. I don't know why it does that. Okay, so if we think 1 is a root, let's divide through synthetically by it and see what happens. Or if you thought -2 was a root, or whatever one you thought was a root, you can try. If there's more than one, it doesn't matter which one you do first. Both of them will work. So 1, and then what are my coefficients?
1, -3. 4, 0.
1, 0, -3, -2. Bring down the 1. 1 times 1. Add them up. 1. 1 times 1. -3 plus 1 is -2. 1 times -2. Hold on. Bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -2. 1 should be a root. Oh, 1 isn't a root. I did it. It was -1. So 1 is clearly, it's not a root. So this is what happens if you check it and you check the wrong one. You don't get a remainder of 0 because 1, it doesn't cross there. Let's try -1. So I still think I'm right. I just did it wrong. What's -1 times 1? -1. -1 times -1? 1. What's -3? Actually, that part stayed the same. What's -1 times -2? 2. Remainder of 0. So -1 is a root. So -1. And how would you write this part?
X squared minus
X squared minus x minus 2. See what happens. So now, find the zeros of this part, but you don't need synthetic division. Once you divide through synthetically by a root, you take the exponent down one level. So you just took it from a cubic. Now you're left with a quadratic, and you can factor that. How does x squared minus x minus 2 factor? X plus 1 and
X minus 2.
let's check x squared minus 2x plus 1. So you get an x plus 1 and an x minus 2. And now you get x equals -1. That's a root. X equals 2. That's a root. And I told you -1 looked like a double root because it went up and touched it and bounced away. So your roots are just -1 and 2. That's how you find the rational roots. So the whole key for this working is you were able to find a possible rational root. Didn't we write plus or minus 2? Thought we did. Should have been there. We were able to find a possible rational root and divide through by it. If you couldn't find a rational root to start, then you're stuck. You're going to have no way to turn this cubic into a quadratic using synthetic division, because you'll never get a remainder of 0. Okay, so I've got to give you one that works nice. And then you can go from there. Right. Any questions on that one? All right. Let's try... Yeah, let's try this one, and then we'll finish with that one. Okay, so find all rational zeros. Okay, what's the first thing I have to write down? P's and Q's. Yeah. What's P in this case? Yep. And Q?
1, 2, 3, and 6.
Okay. So if this crosses at a fraction, it's going to have to be one of these. And it's basically 1, 1/2, 1/3, or 1/6. That's it. So, possible rational roots. 1, 1/2, 1/3, 1/6. Now, what's the next step? Graph it. We're gonna narrow this list down. Hopefully we're gonna find one that works and then use synthetic division to turn this cubic into a quadratic. And then we can maybe factor it from there and get the other two roots. Or if it doesn't factor, then that means the roots probably aren't rational. You probably have a square root in them. They're probably irrational. So let's graph it and see. So 6x cubed. One other thing they could be that I didn't even mention is they could be imaginary. Okay? We're going to know if they're imaginary once we graph it.
You forgot the minus between the 5 and 6.
Thank you. So this is a cubic. Cubics always have 3 answers. This particular problem only crosses the x-axis once. That means the other 2 answers are imaginary. We're not dealing with them. So let's look at what this could be close to. Positive or negative 1?
No.
Not really. Negative a half?
No.
Positive a half?
Maybe.
Maybe. We'll keep that in mind. Negative a third? No. Positive a third?
No.
Probably not. And then not that. So the only possible option could be 1/2. So if I only have to find this, and it doesn't say how, I'm just going to plug in 0.5 and see if I get 0. I do. So that's it. The only possible rational root is 0.5.
How'd you see that?
So you can do it at the table, second table, and type in 0.5, or you can just press trace. Type in the x value you want to trace to, and check the y value, and it is 0. So the roots are 1/2. That's it. Okay. No need to use synthetic division because I'm not looking for 2 more roots. This isn't like the graph where it crossed 3 times. So if you were to use synthetic division, this will go in with a remainder of 0. You'll get a quadratic, but if you solve it, you're going to have I in your answer. We don't need to worry about that yet.
So you only use synthetic division if you look more than one.
Yeah, if you have to find more. I can tell here that there is not more. Yeah. Okay, and let's finish up with this one. What are they asking me to do here that's different? So what's different from the last one? Real numbers, not just the rational ones. They want them all. So if there are ones that cross at square roots, they want those too. Okay. So what's my first step? P's and Q's. Okay. What are my factors for P?
1 and 2.
And?
Negative 1 and 2.
Yep, so plus or minus 1 and 2. What are my factors for Q?
Positive, negative 1 and 3.
Plus or minus 1 and 3. So let's make a list of possible rational roots. This is exactly how it'll be set up on the test. You'll make a list of all possibilities, and then you're going to narrow down the list using your calculator. So what would be my possible roots? 1. 1/3. 2/3. And which other one? 2. You do not have to put them in numerical order. That's fine. Okay, now what? Graph it. Okay, so let's graph it and see what we got. So 3x cubed minus 8x squared plus x plus 2. So how many real answers am I looking for here?
3.
Definitely looking for 3, and I'm going to be writing all of them. Rational or not? Do any of our possible rational roots look close? I would say maybe, yeah, this one's definitely out. Maybe negative 1/3. I doubt positive. How about the plus or minus 2?
No.
No, that one doesn't really look close. Plus or minus 2/3? Maybe positive 2/3. So I have a feeling only one of those is going to work. Maybe let's trace to the negative 1/3. This is the part that saves us time with the division. I don't want to divide through by something that's not going to give me a remainder of 0. So this will tell me whether or not it's remainder 0. Negative 1/3. No, that's not the root. So it probably was 2/3. 2/3, yes. So the root, one of the roots is 2/3. So let's start a list. That means the other two roots are going to be irrational. So they're going to have square roots in them. And I'm going to look that you tell me the square root. So the only way to get that is to use the quadratic formula. But we can't use quadratic formula on a cubic, so divide through synthetically by the root that you have. It's like you're dividing that factor out, and you're going to get the other factor. And then we'll go from there. Yep.
My calculator's not graphing.
It's not graphing?
Yeah, it's just showing me this page. Error invalid dimension.
Probably because you're on your scatter plot, there's probably something wrong. If you turn off your scatter plot, do you have it? If you go to the top where it says plot 1, 2, and 3, is one of those highlighted on the y equals screen? Turn them all off, and then I bet it will graph.
Thank you.
Did that work? All right, so we got 3, -8, 1, 2. So I'm not really interested in the remainder. I already know what the remainder is going to be. What is it? 0. I'm interested in what I get right here. And I want to use the quadratic formula on that. That's my other factor. So I'm using division to get the other factor. So we got 3. What's 2/3 times 3? 2. -8 plus 2? -6. Let's see. This is like 2 times -6. What's -12 divided by 3? -4. 1 minus 4? -3 times 2/3. And we already knew that. So now, this is x squared, x constant. That's the other factor. You need to find the zeros of that part. So 3x squared. Now, don't even try to factor it, because if it did factor nicely, we would have already seen these answers in the rational roots. They're irrational. So what is A here? B? C? Okay. So -b plus or minus what comes next?
Square root of b squared.
Yep.
It's 4 times 3 times -3.
4 times A times C. Okay. Divided by
2 times 3.
6. So when we simplify that, those are my other two roots. 6 plus or minus, minus a minus becomes a plus.
It's 12, 36.
So 36 plus 36. 72 over 6. And you know what? It's actually better to think of it as 36 plus 36, because then you could think of it this way. 36 plus 36 means it's times 2. So what's the square root of 72 simplify to?
6 times square root of 2.
Yep.
12 plus or minus square root of 2.
Well, 6 plus or minus, what's the square root of 36? 6. And then you can cancel out what from everywhere? 6. Gone, gone, gone. So it's 1 plus or minus square root of 2. Let's see, the square root of 2 is about 1.4, plus 1 is about 2.4. So if you look at that graph and you calculate the 0, hopefully it's pretty close to 2.4. Let's see. Left, right, yes, 2.41. Yep. And the other square root would be 1 minus the square root of 2. So there's no way that the calculator can give you exact answers like that. All right? I'm going to ask for the exact. So you have to use synthetic division and then quadratic form. Okay. Any questions on that? Homework is on 183. And it's those problems. 1, 2, 5, 6, 9, 10, 13, 14, 17, 18, 27. Okay, so we'll take a look at that tomorrow.